So the intermediate value theorem is a fairly straightforward theorem. It is a bit formalized, but really the basics of it are fairly easy to understand. So basically the intermediate value theorem says, and it relies on the condition of continuity. So this is very important. I want you guys to make sure that you make a note of this. Function is continuous. Okay, so it has to have this condition. But if a function is continuous, what we can say then is, if we know we have 2 points A and f of A, and the second point B, f of B, we know there must exist some point W in here, some point that's in between these two y coordinates, and we know that that coordinate must exist somewhere between A and B. Okay? So that's what the intermediate value theorem is stating. So it's a fairly straightforward condition. Okay, and so this is a fairly simple application. If we know that we have a point at -2 and 5, and we also know that we have a point at 8, -17, the question is there a solution to the equation f of x equals 0? Does the y coordinate ever equal 0? Well, this must be true, okay? And this is because of the continuity of this. So if I draw this function, I've got -2, 5, maybe somewhere around here, and maybe I'll just redraw that. Okay, so I've got a point here at -2 and 5. I've got another point here at 8 and -17. Somewhere around there. And we don't know exactly what's happening in between it. You know, all sorts of weird things can go on. We can go up and down, and go like that. We don't know what's going on in between those 2 points, but one thing is true. We know that this coordinate, this y coordinate of f of x equals 0 must exist. Okay, that's the coordinate there. And we know because if this graph is indeed continuous, we know that it at some point, at least once, must pass through that line. Okay, so this is true. Okay, so this is a fairly simple application of it. One very common application is proving that there are zeros of a function. Okay, we can say that we have a point above, we have a point below, it's continuous, we know that it has to go through. Okay, so this is what the theorem states. Now, it's stating it fairly formally in that it's kind of drawing some bounds here. Okay, it's saying that there's a bound here, there's a bound here, and we're making statements about what's happening in between here, and we're saying that it must happen in between these two x coordinates, so it has to happen in there. Okay. Now, what the intermediate value theorem doesn't say is that it can't go past these bounds. Okay, so clearly the way I've drawn this graph, the graph actually goes above 5 and it goes below -17. Okay, down here. Now, even though it goes above and below, we can't make any inferences about it because we can easily draw the same situation. Okay, we can easily draw the same situation where it stays within the bounds. Okay, so we have no idea what's happening above or below. We can't make any conclusions about anything above this line or anything below this line. But between these two lines, we know that between these two y coordinates, between these two f of x values here and here, we know that all these f of x values in between must exist, and furthermore, they must exist inside this x bound. Okay, so that's what the intermediate value theorem is. So here's another one. We have a continuous function. It's defined for this particular interval from -2 to +7, and you're given values f of -2 equals 4 and f of 7 equals -21. Again, same thing here. We're being asked to show that does f of x have a solution x equals 0? Well, if it's continuous, and again, this is important, the condition of continuity needs to exist. Okay? If it's continuous, we can then sketch this out. There is my graph at -2 and 4. Okay, we'll just put it up there. Y equals 4. We'll say 7 is here, and -21 is down here somewhere. -21. And we don't know what's happening with this graph other than we know that it is continuous between those two coordinates. Okay, so does this graph solve the x equals 0, so f of x equals 0? Well, we know that that must happen. Okay, there's no way to get from here to here without crossing that yellow line. So because of the continuity, so we can then state this formally this way. So we can say that f of x is continuous. We need to make sure that we have this condition. Therefore, by IVT, intermediate value theorem, we know that f of x equals 0 must happen between negative f of 7 and, actually it's going to go the other way around, between f of 7 as a low bound and f of -2 as my high bound. Okay, and we know that this must exist, and this must, sorry, I should state this as more concisely as f of c. Okay, f of c must exist. Okay, there's c1, there's c2, there's c3. In this particular case, there's actually 3 c's, but we know at least one exists where c is in between the bounds of -2 and +7. Okay, and this is the intermediate value theorem. Again, it's a fairly simple, straightforward theorem. Okay, it's based on some very basic principles, but it is very useful and is very powerful when we can use these simple theorems. Just to be clear, if this is in fact discontinuous, okay, if continuity is missing, okay, we have a problem, because now from here to here, if I have discontinuity, well, I can very easily draw a graph where the IVT does not hold true. Okay, so that's why it's very important to have this condition of continuity, because otherwise we can easily break up the graph so that such that it doesn't cross that line.